Assalamu alaikum. Today is the last lecture of this course, and inshallah today we will discuss two things. First of all, we're going to talk about using neural network as a classifier. This is, of course, I know this is the last lecture, and some people don't like to have an assignment or an exam on the topic that was discussed in the last lecture. So basically, I made sure in the assignment 3 and in the final exam that you don't need this lecture. If you want to work with it, that's fine, but actually you don't have to. Okay, so basically the assignment 3 and the final exam do not ask questions about this particular classifier. If you want to use it, that's fine, but if you don't have to. Okay, so basically this is a very useful classifier, and we're going to see how to use it in a very similar way to the classification app that we used before. There is another app for neural network classification that I'm going to show you, and we are going to try the data that we already have on that classifier. Then we are going to discuss the assignment 3 questions and the final exam questions so that you understand what you need to do. Okay. Do you have any questions before we start?
No, doctor.
Okay, so let's get started then. Okay, so let's start with a very brief lecture about neural networks, just to give you the idea about what neural networks are, okay? So basically from what we remember from physiology and anatomy, basically we have basically the basic neuron is the building block of the nervous system, basically, okay? So we have here, what we have here in a neuron, basically we have three stages or 3 things. We have the inputs, we have basically a conduction or basically some processing that happens inside the cell body, and we have outputs through the dendrites, okay? Sorry, the dendrites are the inputs, and basically basically the connections here are basically the axon terminals actually are producing output. Okay, this particular neuron or any particular neuron actually has more than just a transmission of whatever we have here to the output. It processes whatever it gets inside the cell body before it sends these signals to the terminals here. Okay. First of all, we have each one of these lines actually have different weights. Okay, so basically each one of them, like this is W1, this is W2, each one depending on where you are, basically until Wn, basically each one has a different weight. So basically it weighs the different inputs differently. Then there is a nonlinear function that happens inside the cell body itself. And basically, whatever it gets processed here gets sent to the output terminals right there. So basically, you can put a very simple model that looks like this, basically. You have the inputs right there, and you have the outputs right there. And you have a nonlinear function in the middle. You can look at this, you can basically have or decompose this function right there as a summation junction plus a nonlinear element. Basically, the summation junction adds these x1 plus w1, x2, x1 w1, x2 w2, and if you have more than 2 inputs, you can just add them together. And basically, whatever gets out of this summation junction gets a nonlinear function right there. Okay. Usually, when we're talking about the nervous system, we have billions of such neurons interconnected together. Okay, so basically we have the outputs from one neuron go to the input to another neuron, and so on and so forth. You can actually connect more the basic inputs from multiple neurons and actually connect to multiple neurons at the output. So people started thinking about simulating that. So basically the field of what's called artificial neural networks started with a very simple model like what we see here, this model right there. This is a model of a neuron, and basically each one of these circles is a neuron basically. Okay, so basically you put these neurons and you connect them to the the neurons before them and the ones after them, and implement each neuron. Basically, each one of these neurons processes the inputs very much like what a regular neuron or a physiological neuron would do. Okay, so basically people started making artificial networks like this. You have here what's called input layer, which basically represents the input that you have, and you have the output layer at the end, and basically this output layer actually is responsible for producing whatever you need to, the functionality that you need from this network comes out at the output layer. And you have several layers in the middle here. We call them hidden neurons or hidden layers. Okay, these hidden layers, they are called hidden because they do not appear in the input or the output. Okay, they are something in the middle that controls the operation of the whole network, but you don't really see them. You cannot access them from the outside. Okay, so basically, first of all, we have to understand how a neuron like this, or basically if you talk about the model like this, what kind of function we would have here, what kind of nonlinear function we would have here. People actually found out that we have to have a nonlinear function in order for neural network to work, in order for us to better simulate what we have in the physiology of the neuron. So basically they decided, or basically the first function that got used actually is what's called a sigmoid function. It looks like this, just never mind the equation, doesn't really matter that much. But actually it looks something like this. It starts from 0 to 1, but goes in a very smooth manner like this. Okay, so basically it transitions from 0 to 1, in a very, very smooth manner. There's another function that's called tanh. Basically, this is for basically if you have a positive, basically here you have like input here is negative positive, this is -1 + 1. Here it's 0, 1. Depending on your inputs, sometimes the inputs you have are from negative to positive. So basically you have to have it like this. So basically this is monopolar and this is bipolar. It looks very similar, but actually this starts from -1 to 1. These functions actually are kind of very difficult to implement on computers. Usually a function that looks like this is complicated, at least. It takes a lot of time. It takes more time to implement. And usually for neural networks, you need something that works very quickly, very fast. So people approximated this with this function right there. So basically assume that it goes from 0 to 1. This is 1 right there, but it goes like a linear fashion like this. Okay, and basically it seems here like what we call it rectified linear unit. It's basically, you can just consider it as this function right there, but just consider that it's rectified. Rectified meaning that the negative part is 0. Whatever goes in the negative part, it becomes 0. Okay, so basically if you have something like this, this is a very good approximation. This is actually very fast, and it turned out that it's very useful as well. It works very well. Okay, and it's nonlinear, by the way. As long as you don't have a linear curve has to be a line that goes through the origin and basically goes to infinity, from -infinity to infinity like this. Okay, this is a linear curve. This is nonlinear because it actually has this rectification right there. This is the reason for nonlinearity. Okay, so this is actually a very useful function. Another one that was proposed is called leaky ReLU. This basically some people abbreviate as ReLU. ReLU is rectified linear unit. Rectified linear unit. So some people actually have a smaller slope here, a very small slope here. That actually some people thought that it would be very useful in some applications, but actually this one here is most commonly used. Okay. The most important thing to get out of this slide is that there are several activation functions, and actually the performance of your neural or artificial neuron would actually depend on which one of these you would use. For example, if you choose a sigmoid or if you choose the ReLU, you're talking about an input from 0 to 1. You're not talking about negative inputs. If you're talking about a negative input, if you have something that has a bipolar meaning that it has negative and positive, then this would be actually much more useful. Here, actually, you can have also negative values, but it's actually kind of suppressed in the negative side. So that the choice of the activation function, this one here, this function that we're talking about, you call it activation function. Is very important. Okay. Okay. So how can we use them? Let's focus on whatever we have on MATLAB so that we can get quickly to it. Okay. First of all, we're not talking about deep network. Deep network actually has many layers. Okay. We're talking about here, we're talking about 2-layer feed-forward neural network. Okay. So basically, for 2-layer, basically we're talking about the hidden layer. Basically, the input is not a layer. Basically, you don't have neurons here, no neurons here. You have neurons here and you have neurons here, okay? But basically, this is why you call it a two-layer neural network. Basically, people found out that a 2-layer feed-forward neural network can be, basically can approximate any function. So you can use it as a very effective classifier, basically. You can train it to be a very effective classifier, okay? It has 3 layers, three parameters, basically. You have the input layer, the number of neurons here, or the number of inputs here, basically, or the size here of this layer is actually fixed by data, basically depending on your data. For example, if our example that we worked with, we had data, the training data were like 128 by 34. 34 features will be the size of the input layer. Okay, you cannot determine, or you cannot select any other value. We basically stick with whatever you have in your data. For the output layer also, you have very specific choice. Basically, it's fixed by the problem. If we're talking about a binary classification, then you have only one input, okay, one output, and this output can be 1 if you have a disease or abnormal, for example, and 0 if it's normal. Okay, so basically this is also decided by the problem. It's fixed, basic. You cannot change it. Okay. On the other hand, the hidden layer, the number of layers, the number of neurons that you're going to include in the middle here, you can select, and this is one of the parameters you should choose. This is one of the things that you are going to design, and based on the design, the performance will depend on it. Actually, it's basically the size of this layer and the activation function are what's called hyperparameters. These are the design parameters that you're going to have in your system. So basically, you can change them and get a different performance for your system. Okay, so basically what we have in MATLAB, we have a training app that would consider something that looks like this. You determine the number of neurons here, you determine that, and the input basically gets from the workspace as we did before, and the same thing for the output here. The output here actually, basically if you consider this input as n by m, n cases or samples, times this is cases, and this is basically features. Okay, and here it has to be exactly n by 1. Okay, this is very important. The size has to be n by 1, n cases or samples. Maybe I should just use the same notation of MATLAB. Just put it like this. Times 1, because basic 1 is the output. You have output either 0 or 1. Here it has to be binary. Maybe I should just put it in another color. It has to be binary. It has to be binary for neural networks. It cannot be 1 and 2. Basically, for the statistical system and for the classification using other methods, we assign the normal as 1 and the abnormal as 2. Here, it's not going to work like this. Here, you have to have 0 and 1. So basically, here you have to assign 0 for the normal and 1 for the abnormal. You cannot have it any other way. Okay? Once you do that, once you have these two, you can train the network and basically get the results out of it. Do you have any questions about the general concept of what's going on there? One missing piece of information is missing is basically how the output gets computed. Basically, in the output layer here, you compute the output. Whatever we get from here, you sum all of these and basically compute the output right there, out of there. Basically, you get from the output layer, get numbers like this. Sometimes it's not very good to get numbers like this. You need to have probabilities. Okay, so basically what they do here is to have certain, just consider this as a normalization step, okay, so that you can get probabilities. Probabilities meaning that if you add them together, you get 1. Summation is equal to 1. Okay, so basically this is done using what's called softmax activation function. If you basically use this function right there, you ensure that whatever you get here will be from 0 to 1, and the sum for all of them will sum up to 1. Okay, so basically this softmax is basically whatever basically compute the outputs, the regular outputs, and basically choose at the end, choose whatever you have the maximum probability for, and basically consider it as your output. So basically whatever gets here, whatever you get here, if you have only one output, just approximate it to either 0 or 1, okay, depending on whatever you get here. Okay, so basically right now what we're going to do is to try to use that on MATLAB. Okay, we're going to go to MATLAB and basically get started with training the neural network. So this is a code that we had last time, if you remember. Let's run it. This is the lecture 11 ECG CAD1. This is the one that we added the classification at the end, basically. This is the classification. Basically, if you remember from this code, at the end we had to put X train and Y train. We put the features for these right there. And basically we had the X test and Y test. In order for us to train for neural networks, I suggest that we add them together. We just combine them into one X and one Y. So basically I'm going to have X neural network is equal to X train. Just put it like that, X train, X test. I'm just gonna go and add these samples together. And basically I'm going to do that also for the Y. Just call it YNN so that we know that it was done for the neural networks. I'm going to show you how. I'm going to try with the training only first, and then I'm going to show you why we need to do that. Okay? Because basically in the neural network classifier, it already takes the training and divides it amongst the, basically it has a part for training, a part for testing, and a part for validation. So basically it has the division for training and testing there. So we don't need to do that. We don't need to train or basically divide them in the variables here. Let's get started with the application. Basically, if you go to the apps, I'll just show it to you here. First of all, basically, I just need to remind you before I continue, basically, the campus license for MATLAB has been renewed. So you can now, as a KU student, you can create an account on MathWorks and basically download the full version legally. Okay, this is excellent. And basically, you can actually upgrade to the newer version of MATLAB, which is 2020B. Forget about this course or use whatever you have, but actually I'm talking about the future. I'm talking about the next term. I'm talking about your thesis. It's extremely useful to have a version like this, a legal version of MATLAB with the full version. Basically, you don't have any limitations with all the toolboxes that you need and everything, so that you can use it later on. So basically, please, you don't have to download it for this course, but you basically advise to download it for later on. Okay. So if you go to MATLAB, if you open, basically I downloaded. Basically, I'm working now on the license, the new license of MATLAB, by the way. there is something here called neural networks. Where is that? Yes, right there. This is the neural network. What you're looking for is neural network pattern recognition. Can you see it? Neural network pattern recognition. So basically, when you open it, it's gonna come like this, and it shows you the. I actually took the picture or the thing that I had here in the presentation. I actually took this so that you understand what's going on in MATLAB. So you have this network right there. It's a two-layer feed-forward neural network. Feed-forward because you don't have feedback. You don't have feedback from the output to the input there. Okay, and this is most of the networks actually that people use are like this. Okay, what we need to do is just say next. Here we're going to choose the inputs. Okay, so now I'm going to start with X train and Y train. Okay, and then I'm going to let you know exactly what we're going to have. I'm going to use the other one that we used before, but actually I'm just going to show it to you right now. Show you what the problem is of using X train and Y train. Okay. First of all, we have a problem here, as I say. You have a problem here because actually when I try to put the targets, the inputs are X train, the target should be Y train. I can't see it here. The problem is that it assumes that you have basically the variables for the targets should be zeros and ones. But unfortunately here we have ones for the normal and twos for the abnormal. So actually you have to go back here. Let's just save this as lecture 12. I'm going to change that to zeros, and I'm going to have that as ones for both test and so that it matches the format that this app expects. So I'm going to run it again so that the X train and Y train actually get the correct values. So I'm going to go back here, and basically when I go back now, once I got X train here, I'm going to find here Y train that become present right there. Okay, so Y train is right there now. I can get it. Okay, samples are matrix columns or matrix rows. Actually, we know that it's matrix rows because basically, if you look at what he writes here, basically the input is 128 times 34, 128 cases by 34 features. So basically, for each one of the cases, you have 1 times 34, which is a row. It's not a column. Okay, it needs you to do that in order for it to understand basically which dimension has the cases and which dimension has the features. Okay, so now you have the training as 128 cases times 34 features, and here you have 128 times 1, which is a target. This is the output, expected output, and basically you can then move on to see what's going on. Now here, look at this here. Basically, it randomly divides up the 128 samples as 70% for training, which is going to be like 90 samples. You have validation, 15%, and you have testing, 15%. It's 19 samples. 19 samples is not a very good idea because if you have only one sample incorrect, you're going to get like a deduction of 5% at least, more than 5%. So we need to have more testing samples, okay? We're going to proceed with this number of samples, and then we're going to use the one that we just created when we added that training and testing, because there is no need actually to divide them because actually they're going to be divided inside. So let's go get the results from here. So this division is okay, so I'm going to say next. Now you have the design of your hidden layers. You can decide what number of hidden layers that you're going to use. Maybe I can use 5. Can try 5. This is 10. We can just keep it 10 for now, and then we can change it later. And this is very important because if you use a very large number of hidden neurons, you're likely to get very good results with the training, but actually sometimes you run into the problem of overfitting that we talked about, because you have so many different parameters that you have to estimate, and you have a very small set of data samples. basically this number of neurons should actually be, it shouldn't be too high, because basically you're going to run into overfitting, and it shouldn't be too low because you're going to run into underfitting. Okay, so basically you have to do that experimentally. Okay, in order for you to make sure that you have this problem or that problem, whether you have overfitting or underfitting, you compare the results for the training and the testing. If they are very different, then you probably have one of these problems. Okay, so you have to readjust the hidden neurons so that you can basically get very similar results between the validation and the the training and validation and the testing. Okay, let's see now. Okay, so we're just gonna keep that as 10 for now and proceed. See here, this is the network now. The inputs are 34 because you have 34 features. It already detected that from your variable, from your input variable. And your choice for hidden layers is 10. The output here is 1 because basically you have either 0 or 1. So you're just gonna say next. Now we got the point where we should actually train. So we just press train. It's already done. Okay. Now the testing here is basically, the error is basically 0%, which is actually amazing. Let's just plot the confusion matrix. Basically, this is the training confusion matrix. This is the validation confusion matrix. This is the most important one, is the testing confusion matrix. You have 100%, okay? Does that make any sense? It doesn't make any sense because the training actually has 98%, 98.9%. It doesn't make sense for the testing to be higher than the training, okay? The point with neural network is that every time you retrain, it chooses different samples, so basically it gives you different results. So basically you have 128 samples. It takes 70% of them, which is 90 samples. It takes them by random, okay? And it trains with them and also does that for the validation and for testing. Depending on how you do that, depending on the nature of the data, you might have different results with different iterations. So basically, if I say retrain, it's going to train the network again. Now you have 0% error in your training, 0% error for validation. This makes sense, actually. Now you have 5% error for your validation. Basically, you just notice that it's written in the exponential format, the scientific format. It's 5.2 times 10 to the power 0, which is basically 1. Okay, so it's basically 5% error. If you look at the confusion matrix, you have only one error right there and the rest is okay. But notice that the number of samples that are used for testing is really few. You have only basically 19 samples. Okay, so basically it's better to just include the whole set with everything, since basically we do the division here already. So it's better to go back and choose now the XNN and choose here the YNN so that we have all the samples. Now we have 192 instead of 128. So basically this will help us get a higher number of samples for the training and testing. Now we have 134 samples for the training, and we have 29 samples for the validation, 29 samples. It's much better than basically than the other one. We had like 30% more or 50% more samples in the training and validation, which is actually going to result in better results. So now we're going to keep that, the 10. Basically now you have the inputs exactly the same format, everything is the same. And we're going to now train. Now the results here actually might make sense. Actually, it's if you keep training, retraining, you see that the results don't change by much, but actually they change. Definitely they change. Okay, so the best way for you to get the actual result is to do that several times, like what we did with the cross validation. We do that several times and average. Like it's very much like cross validation, n-fold cross validation. You try that
5 times an average, and this would be actually a very good estimate of your testing accuracy. Okay, the confusion matrix is the same. Basically, if you look at this here, this is a test confusion matrix. It looks very good actually, but yeah, now if you notice that there is no balance here, basically since actually it's selecting 29 samples at random, so sometimes you get imbalance. Basically, you have basically the number of true positives here is basically this is true negative, and this is a true positive. Basically, the true positive is much less than the true negative, which is really strange. Actually, it shouldn't be like that. Okay, it shouldn't be it should basically be balanced, but actually here it's not balanced. So basically, it's a good idea to retrain until you get something that has balance. Here also you have 6 and 19. Doesn't make sense. It's kind of unusual to have it like this. Okay, so basically you need to have something that would have more balance in the testing. So retrain again. Look at the confusion again. This is a little bit better, but actually still not balanced. 10 and 16 is not really balanced also. Okay, so basically it's better to retrain again. Let's just keep retraining until we get something that would be actually better. Okay, so here it's actually 17 and 12, still not balanced. What you can do is if you want to basically get some testing results that are specific or basically has a particular balance, you can actually do additional testing. So basically I can come here, once I did the training, I can come here and choose another variable. So basically I can choose here X tests. And the labels would be the Y tests. Okay, and basically I'll test the network here now. So basically I tested the network with these data here. So now when I plot the confusion now, basically you're going to have balance here. Okay, you're going to have, now it's 31, basically the total for the target class is 32, the total for the basically the normal and abnormal are both 32. So basically now this is a more realistic estimate of whatever you're getting from the neural network. Okay, so basically the optimization here is to go back and maybe select a different number here. Even if I choose 5 and retrain, now I get this result like 3.4% right there, error. Okay, and maybe retrain again. Here it's about 10%. Here, what I need you to notice is that the numbers are not very different. Okay, so here you have 6%, here you have 6.8%. This is actually an indication of not having overfitting. Okay, now this is 2%, this is 0%. They are very close. They are not really that different. Here also it's very close. So this is actually not bad. Okay, so here you have the data. Of course, there's imbalance here, but still the results doesn't look really bad. It's they look okay. Okay, even though it's 93%, but actually there's a balance between these two. Okay, so you keep retraining and basically get like 5 results from the testing, and basically average them and get your result for the cross validation, the n-fold cross validation. Okay, so basically once I did this, once I actually wanted to or got the results that I want, I can just go back or go ahead and basically generate codes for the actual network. Okay, so basically whenever you're trying to train the neural network, you're basically estimating the weights here. Whatever you have here, you estimate the weights here based on your training. And the adjustment of weights is basically what defines the network. Once you determine the weights of this network, that's it. You can use it later on to estimate or classify different inputs. So here, the code that we got here is actually the code for the network. Here you have the offsets and the gain, basically. You have the parameters that would define each of the neurons. You have the values that you actually got after the training. So basically, it's a little bit different from the code that you got from the classification learner. The classification learner would give you the learning function. Here, it gives you the output neural network with the actual weights that you're going to use. So basically, this network or this function right there, you can put here your X test and get your Y test right there. So you can estimate for different inputs. You can estimate the output using the network that is defined right there. Okay. So basically, the neural networks, basically this is a training. Basically, it shows you the parameters of the training, but actually this is actually a part of the same app. It just shows you what happened, okay, how much time and the performance and things of that sort, just to learn how the training happened. But actually, the most important part is the part right there. Okay, so that's it. This is it for the. Basic, you can save the results, of course, you can save the network itself. It depends on what you want to do. But at the end, you can actually use this app to do a classification for any data that you have. Okay? If you want to learn a little bit more about this app, actually, you can choose, instead of choosing your own data, you can choose sample data, example data. There are several examples in MATLAB that have data that you can use and basically classify using this app. You have actually, there are some data for breast cancer actually, but the breast cancer data here is not from the images that we saw. Basically, these are like things that people measure from the images and put like numbers, like clump thickness, uniformity of cell size. These are actually pathological features actually. They are looking at the cells under the microscope, things of that sort. So basically these they classify breast cancer from the samples, from biopsies, okay, not from the images. But actually, it's a very interesting way of looking at it. Basically, you can look at this data set as well and basically use it with this app and basically get the experience you want to use it later on for other things. It was important for me to actually talk to you about the neural networks because they are, among the best classifiers that you can actually use. They are really very useful. So along with the statistical classification methods, together you actually have a very nice toolbox of things that you can use later on in your thesis, okay? There are other more advanced neural networks, which are called deep neural networks, which actually contain so many different, or basically have different configurations, and they have much larger number of layers, okay? Some of them actually have like 100 layers, okay? And these layers actually also have different functions or different ways, not just the fully connected ones that we saw here, but actually they are mostly used with images, not with signals, okay? So basically, for the signals, the regular neural networks or the shallow neural networks are actually much more than enough. So I hope that you understood what I basically showed you about neural networks. I hope you try it, and I hope you use it for your work, inshallah, later on. Okay? Any questions about neural networks? If you want to go back to the beginnings, maybe I can show it you from the beginning. First of all, we put the samples. Okay, we choose the samples here, and the one that has the features here, and the one that has the outputs here. We have to make sure that the sizes are matching. The first dimension here should be the first dimension here, because basically you have a matrix rows. You have each row represents the set of features you have for each one, and you have to have the outputs as either 0 or 1, because this is the output from the. It's a probability basically. Okay. So when you say that it's 1, then the probability of disease is 100%. Okay, when said it's 0, then the probability of disease is 0%. Okay, so you have to have it between 0 and 1. If you use it 1 and 2, then it's not going to work, because the output of the softmax layer at the end, it has to be between 0 and 1. So it will never be able to match it to 1 and 2. So basically here you choose the data like what we did with the classification learner. Then basically the division here, if you want to change it, you can do that. I suggest that you keep it. This is actually a very good division, but you can try it if you want to. Here you set the number of layers, number of hidden neurons in the hidden layer, basically. And now basically here you have the hidden layers, you have the drawing of the network right there. It shows that you have here 5 and you have the 1. It shows you how the network is. And then you can basically train or retrain, okay? If you retrain, that's fine, it got you some different results. And basically here you can basically test with another data set if you want to, okay? If you have a different data set, if you have an additional data set that you want to use for testing the network that you already trained, you can actually use it here and test again. And after you do that, you can actually do very nice things here. You can generate the function that has the neural network, that trained neural network, so that you can use it later on to classify any cases that comes your way. And actually, this is one thing that we didn't talk about. This is actually, if you want to get a picture of the neural network that you designed, you just click here and save it here. You can save it from this one here. It just shows you the neural network that you designed. Okay? So sometimes it's actually very useful to have that so that you can include in a report or in a paper or whatever. And that's it basically. Okay? You can save to the MATLAB, you can save the results to MATLAB as variables. You just set the variables you want here, and basically that's it, you finish. Okay, so this is one very useful tool that you can use. Basically, I know that this is a lecture, but actually it's very nice to have something like this, because when you work on your thesis, neural networks are one of the things that people like, actually. If you say that I'm going to use neural networks for this application, actually people like, basically would be likely to be impressed, you know, if you use neural networks, because actually they are a really nice tool, a very nice tool, and you can do a lot of things and you can get a very good performance out of them if you train them the right way. Okay? Any questions? Okay, going to finish that. Now what we're going to do for the rest of this lecture is just go over the assignment and the research exam. First of all, you have any questions that you want to ask about them?
No.
We only have 2 students today for some reason. Okay, I'm not sure where the other students are, but it's fine. Basically, I'm just going to go over them, and basically, if any of the other students wanted to ask me any questions about them, I'll answer. So here, basically, what I'm telling you, you have only one problem, and you're going to design an ECG arrhythmia system exactly like the one that we just ran, okay? And it's up to you, actually, okay? And basically, it's up to you to do whatever you want, basically. The 4 types of abnormal condition, we select one, very much like this code right there. Maybe I can just increase the sorry. Not this one. The part where we basically selected the abnormality type, and basically depending on the number here, I'm going to have normal versus either number 1 here, number 2 here, number 3 here. Okay, so basically this is what I'm asking for the first question right here, right there. And basically you should mention how you're going to divide your data into testing and the training and things of that sort. How you're going to do feature extractions, up to you to choose exactly what you're going to do. Feature selection, classification, and performance assessment. The requirements are as follows. Basically, the first one actually is not a requirement. Basically, just, you know, it's asking you to provide your assignment as a report. That's it. Here you need to have, for the feature extraction, you need to implement only one new feature. Just select any feature that wasn't implemented before in the code that you have from the lecture, any feature, okay? and just use it. And basically, when you select or you implement a new feature, you basically decide whether it's useful or not based on feature selection. Okay? Here you describe how feature selection is done. And basically, I'm asking you here, first of all, if you have, like what we had before, we had 39 features, okay? After the feature selection using t-test, we had 34 features. Now I'm asking you to have a maximum number of features as 5, okay? I'm asking you, how are we going to choose these 5? Okay, how are we going to choose these 5 features? I'm not asking you to actually select 5 features, but actually let me know what you think or what you expect you will have to do if you needed to do that. For example, I might just want to look at the p-values and select the smallest values, for example, okay? Things of that sort, okay? Sometimes I can do it using principal component analysis, okay? So basically I can go to principal component analysis and select the first 5 principal components, for example, okay? Things of that sort. It's up to you. You let me know what you think would be a very good way, in your opinion, to do that. One very important note that I would like to give you is that when I'm asking you about something, just give me your opinion, okay? If you give me your opinion, but give me an answer, I'm just gonna give you the grade, okay? Don't worry about whether it's right or wrong, okay? Just give me your opinion, okay? You're designing a system now, okay? I didn't ask you to obtain the optimal selection or the optimal 5. I'm not asking. Basically, you should do that, of course, but actually, it's not a requirement. You might have a justification for another way of doing that. Just give me the answer and why you did, you selected that, or basically a simple justification of your answer, and this should be enough. So whether it's here in the assignment or in the final exam, and particularly in the final exam. Here you want to compare the best performance of at least 3 different classifier families. We already saw that last time. We can run the classification learner on different classification families like SVM, like KNN, like whatever, okay? And get the results from each one of them and basically compare them. That's it, okay? Report the performance in your experiments in terms of confusion matrix. Confusion matrix and sensitivity, specificity, negative predictive value, positive predictive value, and accuracy, okay? In addition to ROI curve and area under curve. All these things you can get from the classification learner app. You get the confusion matrix, okay, from there, and basically once you have true positive, true negative, false positive, false negative, you can compute any metric you want. Discuss the impact of the ratio of dataset division into training and validation or testing sets. Basically, you have that division. In our code, if you're going to use this code, already we did that division actually. Not sure where. Yeah, it's right there. Basically, the learning and testing here were basically already 64 and 32. But actually, if you go to the classification learner app, you can actually choose the ratio of the training to the validation there. Okay, so basically it's a number of folds. Okay, so if I have 5-fold cross validation, it means that I'm training with 80% and testing with 20%. Okay, and you can change that here or there, and basically just try and see what that would affect. Or if you choose a very large number of training samples and very small number of testing samples, what would that affect? How would that affect the results? Just give me your opinion here, based on your experiments. Here we're talking about resampling all the ECG signals to have only 100 samples per second. Notice that we have the data we have here is sampled at all the data, at least in learn data 1 and test data 1, they were sampled at 360 samples per second. So what you need to do here is resample these signals. Okay, so basically you know how to resample signals. You did that already in the first assignment. So basically, what would happen if I all the ECG signals one by one and resample them to 100 samples per second? Would that be enough to do the classification? If I compare the results from the signals that were sampled at 360 to those who were basically sampled at 100 samples per second, what would be the difference? Would the 100 samples per second be as good as the 360 samples per second? So basically you need to do an experiment with a particular classifier with the original signals and resampled signals, and just let me know which one is better, whether they are the same or they have differences or whatever. That's it. Okay. So basically, yes. Go ahead.
بالنسبة يا دكتور الملاحظات والآراء اللي مثلا آرائي أنا أحطها في الريبورت صح؟
Yes.
Inside the report itself, PDF report.
Yes, PDF report, yes.
Everything.
I don't need code here. I don't need your, basically if you want to have code, you basically can send code with the PDF, okay?
But the important thing, the PDF, I must write my opinion and which one it's okay, and 100 sample by second or.
Yes, you say that which one is better and why. Basically justify every answer that you have. Basically based on what, okay? Okay. It's not like they are the same, that's it. No, you have to actually show me the results, okay?
Okay, the result, can I copy the result? It must be copy the result and put it in the PDF, right?
Yes, yes.
That's it.
Yes.
Okay.
Basically, do it the way you like it, okay? Do it the way you see it makes sense. Basically, imagine that you're asking someone this question. What would be enough for you to, yes?
We will be doing, inshallah, our best.
Okay, no, don't worry. And I'm sure if you did like what you did before in assignment 1, assignment 2, you'll do very well in the in these two, the assignment 3 and the final. Okay. Okay. So you shouldn't worry about it.
Okay, doctor.
For the rules here, basically the rules are just fine, but actually it's the most important thing. This assignment is 15. Sorry, it's 15. I'm sorry. Oh, sorry, it's 50. I'm sorry. This is 50. 15 is the research problem exam. Okay. So basically, it's 50 marks. This is very important. And basically, this is what you can actually use to do a thesis, for example. Basically, it's exactly the same tools here. If you remove the ECG arrhythmia and put, for example, heart sounds, put the EEG, put whatever other signal, basically you can do another thesis with exactly the same tools that you learned in this course. So basically, this is very useful. And that's why I made the marks here as 50. Okay. For the research exam, basically, they are intended, all the problems are intended to be in things that you didn't see before, okay? Basic, I'm talking about functional MRI, I'm talking about maybe a different kind of ECG signals like this. Things that basically are generic questions that I would like to use to basically see how you could generalize the information that you got in this course. Basically here, even if I don't know exactly, if I just remove the source of basic description of the source of the data, I have a signal that looks like this. I want it to be like this. Okay. Obviously, I need a filter. What kind of filter? Basically, you should if you understood exactly what we were doing in ECG, basically you would understand what to do here. Also, this is the same thing. A signal with a noise. Your role here or your task here is to understand or basically examine the signal and determine the noise source and basically propose what you're going to do. The very important thing about the final exam is that I didn't ask you for any code. I'm not asking you to do any coding. Just write whatever you're going to do. What you would need to actually do this. Okay, So basically the answer here will be very simple, maybe a couple of lines, okay? If you found yourself copying stuff from the internet, if you find yourself that the answer to any one question taking like pages, you're doing something that I didn't ask you to do, okay? The answers here should be very brief, extremely brief, just the idea, okay? Don't worry about being too brief. If the answer is too brief, if the answer is not clear, I will ask you. But after you submit, I will ask you what you meant by that. What did you mean by that? Okay? So don't worry about it. Just put your ideas here, and that's it. The main idea, and that's it. For example, I'll say that not for this particular problem.
That is only answer. There is no coding.
Yeah, there is no coding in the final exam. No coding in this exam, no coding whatsoever, okay? It's written right there, basically, okay? You do not need to perform any computations or coding. No, nothing at all. So basically it's not, it appears like an exam and it's difficult and things like that, but actually it's just a matter of basically making sure that you can generalize the ideas that you got in this course, that's it. Okay, so there is no coding whatsoever in these problems. Here I'm asking you about the meaning of linear and nonlinear phase filters and zero phase filters, and basically you basically when I ask about showing examples of cases, basically just write down examples of cases. Okay, where did you encounter before linear phase filters? Okay. That's it, okay, for this here. And basically here also a question about which one of them would provide the minimum initial transient period. Basically, all these things were in previous assignments, and just want to make sure that you understand them. It is desired to compare two signal samples at rate 500 and 860. What should you do to enable direct comparison? We saw that as well. You're giving clinical data set for a binary classification problem, normal versus abnormal, including 14 different measurements taken for 100 cases. How can you make sure that a particular measurement, like the body temperature, is relevant to the classification? Each of these is feature. What I'm asking you is whether a particular feature is useful. What would you do? Here I'm not asking you to actually test a data set to do that. No, I'm not asking you to do that. I'm asking you about the methodology you would use to do that. Here also I have an image of EEG samples, okay? Here we have normal cases, basically the things to the left here are the normal. This is how the normal EEG should look like. This is an abnormal EEG. In your opinion, if you're trying to basic design a classification system, a CAD system, like the one that we use for arrhythmia classification, if you want to discriminate between these two. Basically, what kind of feature would be useful, in your opinion? Very important. This word is very important, this expression. In your opinion, just give me whatever you think and why. That's it. If you do that, even if your answer is incorrect, I will give you the grade. I will give you the marks for this question. Okay? I'm not going to look for answers that are in my mind, okay, my opinion, okay, and ask you to make sure that you got the answer in my mind. Okay, no, it's not like that. Okay? Here it's like a search on the internet. If you want to get some samples, okay, where can you get samples for physiological signals from the internet? Just look and describe one resource that has different samples from physiological signals. Okay? Here describe in brief the difference between parametric and non-parametric statistical classification techniques. This is also a search on the internet. Okay? Just look and basically read whatever you have on the internet and give me a brief answer. I don't want you to copy pages and pages. Basically, here you can find pages and pages, okay? I want you to read whatever you have found on the internet and just summarize it in this question. That's it. So I believe if you work on this exam basically for a couple of hours, okay, with a clear mind, you're basically early in the morning, something like that, you're fresh and basically you're not tired, basically you can finish it in a couple of hours, okay? I'm not asking you to submit it now, I'm asking you to submit it basically after the assignment 3 deadline. But please note that the deadlines are very firm because I need to submit the grades. I need to grade first and submit the grades before a deadline, okay? So you need to adhere to the deadlines that are posted on Blackboard, okay? So do you have any questions? Please, one more advice for you, simplify for yourself. Basically, if the question, if you can understand it, you know, to be asking for something very simple or something very difficult, please simplify. Basically, just answer the thing that you think the question asks about, okay? Basically, if you're not sure, basically, you know, do your best. Just understand what you have in the question, what you see in the question, and answer based on that. Okay. Basically, if I see that you understood something different, it's okay with me, actually. Okay. As long as you understood in a particular way that makes sense, that basically the question bears, you know, some resemblance to what you're talking about, it's fine with me. Okay, so don't try to ask too many questions about the questions. Okay, just work on the questions the way you understood them, and it should be fine. Okay, so from now till the end of the or to the deadline of submitting these assignment and exam, basically you should feel free to contact me if you have any questions. If you need to have a meeting, maybe you can arrange a meeting on Zoom. I suggest that you try to do your best and submit as early as possible so that I can give you feedback if I needed to. Okay, and just make sure that you got the best grade that you can get. I hope you all get A+. Okay, I know that definitely you guys did very well in the assignment 1 and assignment 2. So basically, I hope that you actually do well in the or do as well in the assignment 3 and the final exam, so that you can actually get your A+. Okay. Do you have any questions?
ولا نستغني من مساعدتك.
Thank you. But actually, just make sure that basically just make sure that the deadline is you know, is met, and try to submit early before the deadline. Okay, please.
We will be try دكتور ولا نستغني من أي مساعدة منك.
كتر خيرك، شكرا لك.
لا نستغني من توجيهاتك، والله يجزاك عنا ألف خير يا دكتور.
الله يكرمك.
واعذرنا إذا جاك منا أي مضايقة أو تثقيل.
Don't worry about it at all. Just I hope that you get the best out of the assignment and the course, and inshallah يعني do well in your thesis inshallah.
إن شاء الله يا دكتور. إن شاء الله. الله يعطيك العافية.
So good luck, and I'll be waiting for your submissions inshallah soon.
Okay, doctor. The deadline for third semester assignment, it is in second 12th, right? Yes. Okay.
Basically, we have I'm talking about, yes, basically 12th, yes. Okay. Yes, Saturday, Saturday, the 12th. So it's about a couple of weeks from today, inshallah.
Okay, thank you very much.
Good luck, inshallah, and see you, inshallah, later. Okay?
دكتور إذا كان في ملاحظات على الأسايمنت
I will let you know that.
ممكن وإن شاء الله نحن نعدلها بإذن الله.
Yes, sure, no problem. But the most important thing is try to submit as early as possible so that you can have time to do that, because I have to submit the grades by the end of that week, maybe at the 18th or something like that. Okay? But don't worry about it. Inshallah, we will not need to do that, inshallah.
شكرا يا دكتور.
يلا, good luck, inshallah. Good luck for all of you.
السلام
عليكم.
عليكم.